Hi all, today we will discuss about attention models. Now all the large language models you see in the market right now are based on transformers, and transformers are indeed based on attention model. Now attention came into picture with a famous paper called Attention is All You Need by Googlers, right? Now this let's see why attention is really required and what was the drawback of the previous models, right? So prior to attention, all the language translation and language summarization task was done by RNN based models called sequence to sequence. Now in the name sequence to sequence, it signifies that input is also a sequence of tokens or sequence of word, and output is also a sequence of word, right? So if you are converting from English to French, let's say, so all the input words you see is a sequence and output is also a sequence. Same about summarization and any other language task, right? Now there was a problem with a sequence to sequence model. Let's see how they worked. uh, your model go step by step, looked at all the tokens, all the words in the sequence, input sequence, and then it encode all the summary of those words into a latent space, or famously known as hidden space, right? So everything whatever you learned from that particular sequence, now that sequence could be of 200 words, it could be a complete book, or it could be even bigger than that, right? So entire thing you go learn sequentially and put it into a latent space, right? Now while you are creating the output, you refer to that latent space because it has everything whatever is required or whatever is learned, and then you go back to that, you keep on creating output words, and next word is indeed combination of the latent space where you have gathered all the input encoding and the previous word. So two things, previous word and the latent space, that is how next word is created, right? Now you can easily see two problems here. It is sequential, that means unless and until you process entire input, you will not be able to produce any output, right? And that too, input could be any long, right? It can be of varied length. Second thing is, most of the context is getting lost when you actually encode things, right? So let's say you are summarizing an entire book, 300 pages, 500 pages book, and latent space is small. So you are just relying on that latent space information, whatever it could encode, other information is lost. So summary or whatever you get out of it was of very low quality. So that was a very big problem, right? Now what attention model do is, it doesn't rely on single latent space or single space where all the things are encoded. It relies on multiple such weights, right? So when you go into reading the sequence, you just don't do parallel sequentially, you do it parallelly. And also for all the important parts, there will be weights assigned to all the important parts, right? So whenever output is produced, it goes back and see, okay, these are the important weights all across the input text, and looking at those all inputs, it produces the output sequence, right? So you are now no longer relying on single latent hidden space, you are relying on lot of different input sequences based on their weights. That is how attention solve a lot of problems. Now text summarization and other tasks become much more easier. We'll see self attention, particular concept which is used in a lot of large language model in next video, but this is all for this video. Thank you.